So this video clip starts us off on some specific trigonometry and Pythagoras details. We have to look at the parts of a right angle triangle. We indicate it's a right angle triangle with a little square in the corner showing the 90 degrees, which is the right angle part of the right angle triangle. And so I'm going to label some of the parts, but before I do that, where they come up in physics is pretty much all over the place. Vectors are the usually one edge of the right angle triangle, and vectors can be broken down into horizontal and vertical parts, which you then need to be able to do calculations to find those unknown parts. Sometimes you're given this part and you're given an angle and you have to work out the other part, or you're given two sides and you have to work out the other side length. So that's what this short series of videos is about. So getting into the parts of the right angle triangle, the side that is directly opposite the 90 degree is the hypotenuse. The hypotenuse, H, not it, H, capital H, the hypotenuse. You can just call it H, I'll probably call it hypotenuse in there. Now, you might have seen these things before, sa, ka, toa. Sine theta equals opposite over hypotenuse, and there's an adjacent side as well and different things there. We need to be able to define which is the opposite and which is the adjacent, since we've already dealt with the hypotenuse, which appears in the sine and the cos. So we need to just pick an angle. I'm arbitrarily choosing this one, we'll call it theta, and the opposite side is the side that is opposite. Okay, this is where it comes from. Okay, it's opposite to the angle. It's not always that vertical one there, because you could have this side down the bottom being the opposite if your angle was up the top here. But you find the opposite in reference to the where the angle is, and that would make this one the adjacent because it's adjacent to or next to the angle that's given there. Okay, so if I was to give you another angle up in the top corner here, we'll call it phi rather than theta, all these wonderful Greek letters. The opposite side to phi is over here. So this side length down the bottom is now the opposite, just what I was saying before. And the side length that is adjacent to will be side phi is now A. So you would come up with a different sine equation for those. I'm hoping you're familiar with those equations by now if you're looking at physics. Even at level, you don't really use it at level 1, but level 2, it's absolutely vital. I cannot say how important it is to understand and to work well with vectors. To be able to do that, you need to know Pythagoras, and you need to know your trigonometry. You just must be able to use it. So these few videos are giving you a start. I'm going to look at how to use formula triangles to do them as well. But go back, re-watch it, make sure you can find out which is the hypotenuse. It's always the side opposite the right angle triangle. In fact, even for the change in angle. And the theta situation, the opposite side is the one opposite there, and the adjacent side is the one right next to it. Adjacent means next to. Okay, go back, watch those, make sure you know the parts of them, and you can talk about them as fluently as you would speak about your holiday at the beach using that terminology.